that the square root of x1 equal to the square root of x2. Now, we want to see if the square root of x1 equal to the square root of x2, because, sorry, that is x2, I didn't write it correctly. So here I have square root of x1, I'm going to repeat, equal to square root of x2. I can square both sides. You can square both sides. Then here I'm getting x1 equal to x2. So what happened is that we started with f of x1 equal to f of x2, and then we ended up by getting x1 equal to x2. Then it means that f of x equal to the square root of x is actually is a one-to-one function. Now another way of looking at it, so you can tell me that, oh, prof, sorry, sir, how is the horizontal line test coming into play? Now let's say we try with the first one. The first function is f of x equal to x. If you sketch when x is 1 is 1, when x is 0 is 0. So let me use a different color. So this is when x is minus 1 is 1. This is the graph of f of x equal to x, or you want y is equal to x. So now if you take the horizontal line test, you see that the horizontal line test is like you test it like this. Does it touch many times or does it touch only one? So if 10 of us sketch a line, 10 of us use the ruler, so which means it touches only once. It doesn't touch more than once. It touches the graph only once. Now let's go and see another case. Now if you see another case, let's say the second one was f of x equal to the square root of x. If you try to sketch this function starting here and going, now you're trying to use the horizontal line test. The horizontal line test, when it goes, it touches this graph actually only once, you see? If you draw so many horizontal line, you will notice that it's only touching the graph once. So it's just is a one-to-one. Now we take, let's say, something that is slightly, now a homework. F of x equal to x squared. G of x equal to the square root of x squared minus 1. Determine, or in fact, h of x equal to absolute value of x plus 1. Determine whether f, g, and h are one-to-one function. Great. Let me come and see if there are questions first. Any hands? Any hands is up, guys? Any question on one-to-one functions?
Okay, so say, according to my
Yes.
understanding, can I say a linear graph is a one-to-one function because the horizontal line touches only once?
And not necessarily, but for a linear graph is obvious because it's the graph doesn't have several, so that's why obviously that you can see that, okay, for a linear graph is a one-to-one automatically because the horizontal line only crosses one. Yeah, but the graph, the square root of x is not a linear graph. So in fact, basically, I see what you're saying. Yeah, when the function is linear, is automatically one-to-one. Yes, that is also true. Are you with me?
Yes, sir, I'm with you.
Yeah, okay. Uh, so yes, any linear graph is, it is, as you mentioned, is a one-to-one. But there are some graphs that perhaps also might be not linear. They also be one-to-one. So for your case, that let's say the square root of x is not linear because it's x to the power half. So obviously, it is not necessarily linear, but it's also a one-to-one, right? But you see that was a special case. So basically, you can also add 1 over square root as another function. All right. Any question, guys? Okay, I might
Can I
also
add,
add for you maybe. Yes, go ahead. I'm adding
isn't
another
it
function. Yes, yes,
isn't it
sorry.
g isn't it g at x equals to the square root of x squared minus 1 also a linear function?
No, no, not linear, because you see, if we try to write it, if you have the square root of x, it's basically x to the power half. That's the same works for the square root of x squared minus 1 is actually x squared minus 1 to the power half. So basically, it's not necessarily a linear. It might behave like a linear when you look at it, because there is an x squared inside the bracket and then there is a power half outside the bracket. So it looks like it is a linear, but it is not a linear. Not that is straightforward as linear
Oh,
as you mentioned. Yes. So in fact, maybe I should give more homework. Let's say take, let's say, f1 of x, let's say equal to let's say 2 over x, and then let's say f2 of x equal to, let's say, minus 2 divided by x squared, something like that. So these are various different type that you need to look into. um, let's say I take maybe f3. F3 of x is another homework, is, let's say, 1 divided by the square root of, let's say, x minus 1. So try to, in each situation, determine the domain, which is the most important one. Determine the domain, perhaps also the range if you want, but determine the domain, and also find out if the function is whether it is one-to-one or not. Right.
oh,
Okay.
Sir,
Yes, go ahead.